Hi guys, so today's video is going to help to explain which differentiation formula you should be using when you have different differentiation questions. So this is a common mistake made by a lot of students. Sometimes the hardest thing when differentiating is identifying which formula that you want to be using. So we'll be going through the main differentiation topics today. So we'll start off with chain rule, and we've got some quotient rule and some product rule questions as well. Okay, so how can we tell if we need to use the chain rule? So we'll start with the chain rule here. So the chain rule, we have differentiate f of x is equal to 3x squared plus 1 to the power of 4. Now, because I don't have one x variable sitting outside my bracket here, I just have a bracket to the power of something. I know I can use my chain rule here. So chain rule is all about helping you to differentiate units that is to a large power. So it's quicker to use this rule rather than to first expand out that power of 4, for example. Okay, so the chain rule says that what we need to do is bring out the power at the front to start off with. So if we have f of x is equal to 3x squared plus 1 to the power of 4, we want to times it by that power. So I bring 4 out the front, rewrite what's in my bracket, plus 1, so this is f dash of x is equal to, or to the power of 3, so the power minus 1. And then what's super important is that we need to times it by the derivative of what's in your brackets. So if my brackets here, if I make a new f of x, and that's equal to 3x squared plus 1, my new derivative of f of x is going to be 6x. So therefore I want to make sure that I'm timesing this by 6x. We're not quite done here. What we then need to do is multiply these two numbers together to make sure that we have a fully simplified version. So we just have 4 times 6, which is 24x, 3x squared plus 1 to the power of 3. And that's f of x or differentiated now. So super important here, whenever you have a large power with the brackets, straight away we can use our chain rule, which just involves multiplying the power out the front and then timesing it by the derivative of what's in your brackets. If we move on, we now have differentiate x plus 2 over 3x minus 4. So straight away I can see that this is a fraction. So what I'm going to be using here is the quotient rule. So the quotient rule states that if we have two different variables of u and v, so if this here, u is equal to x plus 2, what's on my numerator, and v we can let equal to 3x minus 4. We have the quotient rule, which says that the derivative of any fraction is going to be v u dash minus u v dash all on v squared. So that means that we need to find u dash and v dash. So if we write off to the side here, u is equal to x plus 2. U dash is then going to equal to the derivative of that, which is just going to be 1. V is equal to 3x minus 4, and therefore v dash is going to be the derivative of that, which is just 3. So now that I've got my 4 variables here, I can then use those to substitute it into my equation. So I have f dash x for x plus 2 over 3x minus 4 is going to equal to my v value, so 3x minus 4, then my u dash value, which is just 1, minus u, which is x plus 2, times by 3, all over the denominator squared, so v squared. Okay, simplifying this across, we just have 3x minus 4 times 1, which is just 3x minus 4. Then we have negative 3 times x plus 2, so that becomes negative 3x minus 6, so being careful of that negative there, all over my same denominator, 3x minus 4 all squared. And now what I can just do is simplify my numerator. So I can see that these two terms at the front cancel out, and therefore I'm just left with negative 4 minus 6, which is going to give me negative 10 over 3x minus 4 all squared. So you can leave your fraction like that. You don't have to simplify the denominator by expanding it out. What's super important with these kind of questions, so if you just identify that you are using the quotient rule, so if you have identifying that you are differentiating a fraction, if you write your u and your v variables to start off with, the marker is going to give you at least 1 or 2 marks for that. Okay, even if you can't get to the final differentiation step. All right, so the last main rule is the product rule. So the reason why I chose this question for the product rule as well is a lot of students I find do get mistaken to when to use the product rule and when to use a chain rule. So when we were doing the chain rule before, we saw that we had a bracket to the power of something. So just by looking with what my knowledge I have straight away right now, it kind of looks like I have to use a chain rule. But this is a common mistake that some students make. Here I'm actually going to be using the product rule. And the reason for that is because I have an x variable sitting at the front here. In my equation 1, where I used the chain rule, I didn't have any variable at the front. So what this technically is I have f of x is equal to 2x times 3x plus 1 all squared. Now, this is not the same thing as if I just had a 2 sitting at the front. It needs to have some value of x or the value that you're trying to differentiate. Here I'm differentiating with respect to x, so since I have two separate x variables that I can write as a product of one another, I need to be using my product rule. All right, so my formula for the product rule, once again, I need to identify my u and v variables. So I'm going to let u equal to what my first product is, and v equal to my second. My product rule is the derivative f dash x is equal to vu dash plus uv dash. So therefore, once again, finding the derivatives of u and v, I have u is just going to equal to 2x, u dash is equal to 2, v is equal to 3x plus 1 all squared, and therefore I have v dash. Now, to differentiate v, like we saw before, we do need to use a chain rule here, but that's not all we need to do with this question. So you can see we are using the chain rule to differentiate v, but that's not how we differentiate f of x as a whole. Okay, so to differentiate this, same rule as before, we bring the power out the front, write the same bracket, minus the power, so 2 minus 1 is just 1, so to the power of 1 I can just leave it as it is, and times it by my derivative of my brackets. So my derivative of my brackets is going to be the derivative of 3x plus 1, which is just 3. Simplifying that again by just timesing my two numbers out the front, I have 3 times 2, which is 6, outside of 3x plus 1. Awesome, so putting that into my formula, I now have my v, so 3x plus 1 all squared, times u, which is 2x, plus u times 2, plus u, which is 2x, and then my v dash, which is 6, 3x plus 1. Simplifying this, so I have 2 sitting outside of 3x plus 1 all squared, plus timesing these two together, I get 12x outside of 3x plus 1. Okay, probably the easiest step for this question here is to pull out a common factor of 3x plus 1. So taking out 3x plus 1, I have 3x plus 1 outside. Then I have 2 times another set of 3x plus 1. So I can use the distributive law here. So 2 times 3, which is 6x, plus 2 times 1, which is 2. And then I just have plus 12x. So this 12x sitting outside there. Simplifying that, I have 3x plus 1 and 18x plus 2. Okay, so that's how we differentiate this, the 3 different types of differentiation rules. Hopefully that helps you to identify whatever problems there. So the easier that, the better that you're able to understand the 3 different types of differentiation problems, the easier you'll be able to get the hang of it and see lots of patterns pop up in the different kinds of questions that you do. Okay, hopefully that helped.